tangent. I see center O there, right? ABCD, sorry, ABC, 3 points on the center on a circle with center O. DE is a tangent, right? And then that angle is 35 degrees. Sure. So what we have here, I'm sure you can see that this is a radius and also this is the radius. So that means this is an isosceles triangle with 35 degrees there. Okay, that 5 there automatically. What does that mean? This is 70, 35 plus 35, 70. So this means this is 110 degrees to make it 180. And then half of 110 is 55 degrees. So this is 55 degrees. Remember, angle subtended by the same chord at the center is twice angle at the circumference, right? And they should check here nicely, right? There's a tangent and the radius there. This angle is 90 degrees. So 90 minus 35 there, we get 55 degrees. So this small angle there is 55 degrees, right? That's 55. What can we do? What can we do? What else can we do here? Right. All right, super. You see, if you combine these two angles here, this is 75 degrees. That means this angle is also 75 degrees. Yeah, of course, you can also use the idea of a straight line there, right, to get this one. Now we need to find that small angle in between here, this one. 75 plus 35, what you get? 75 plus 35 plus 55, you get 165 from 180, right? This is 15 degrees. This angle here is 15 degrees. So if we do this, if we cut through there, right, that means this is also 15 degrees. And then 15 minus 55, this angle is 40 degrees. Perfect. It tallies with that one. I'm sure we've answered everything. Let's see down there. Find AOC. AOC, that's 110. Okay, we got 110 there. ABC, ABC, that's 55 degrees, right? And then DAC, let's go back. DAC, it's also 55 degrees now. 55 degrees. OAB, OAB, that's 15 degrees. All right, super. We got this one right. Okay, so you can always double check. Yeah, there's so many ways of getting these answers, but then you just have to be vigilant there. Right, number 3, we have a circle there. Diameter is QR. Once you hear diameter, remember they say the theorem, angle in a semicircle is 90 degrees, right? That angle is 90 degrees. So when you say 90 minus 74, what do you get? Should we get 16 degrees? This angle here is 16 degrees, right? PRQ is 16 degrees, right? What did we use? Right, we used the 2 theorems here. Firstly, it's angle in a semicircle is 90 degrees, and sum of interior angles of a triangle equals 180 degrees. All right, so that's what you basically use there. Let's see here, we have some parallel lines, right? You need to be vigilant. All right, A, B, C, and D are points on a circle, AB is parallel to DC and angle ACD is 32 degrees. Chords AC and BD intersects at E, sorry. Find the value of X. Right, quite interesting. Very interesting. Right, let's see how this goes. We know we have alternate angles. If this is 32, this is also 32. That's 32 degrees. Right, and then what's next? What can we use here? Right, is there anything? AB is parallel to DC, and wait, I made a mistake there. Sorry about that. Right, this is alternate to this, so this is 32 degrees using alternate angles. Right, that's 32 degrees there. 32 here, 32. And then we know we have a chord, AD is a chord, so subtends that, so this is automatically 32 degrees as well. And of course this is a chord that's also 32 degrees up there. And this is a triangle, 32 plus 32, that's 64 from 180. So saying 180 minus 64, 180 minus 64, we get 116. So X is 116 degrees. Yeah, you must be careful sometimes, you know. Be extra careful there. Right, there we go again. There's some parallel lines here, but there's a cyclic quad. We have a tangent there. Quite interesting. Right, so A, B, C, D are points on a circle. EF is a tangent of the circle to the circle at A. AB is parallel to DC. Right, let's fill in. Let's not rush to answer the questions. Alright, so this angle here is 35 degrees. Right, angles in alternate segments. Right, angle between a tangent and a chord, and then the same chord carries an angle at the circumference. Right, let's see, there's parallel lines, maybe they might help us. This is a triangle now. 60 plus 35, 60 plus 35 there equals 95. From 180 we get 85 degrees. 85 degrees there. Right, what do we have now? Let's see. This can help us. Maybe if we extend some lines here, we might get something. Right, if you see there's a transversal line. Right, let me try to make it clear. If I extend there and extend down here, right, they have alternate angles there. This angle and that one, so this is 35 degrees as well. That's 35. And then if you look closely, A, D, C, B is a cyclic quad. So this whole angle 60 plus this one must give us 180. So this angle here is 120 degrees. Okay, and then when we add 85 plus 35 plus 35, we must get 180. So it can help us to get this one, or we can use the idea of a triangle there. So 120 plus 35 equals 155 minus 180. What do we get there? This angle is 75 degrees. Right, I think we've covered almost everything here. But of course this is also 85 degrees. Angle between a chord and a tangent, and then the same chord carries an angle there. So let's answer the questions down here. See, DCA, wait, sorry, DCB. That's 120 degrees. These are opposite angles in a cyclic quadrilateral. quadrilateral at to 180 degrees. Find DBC. DBC, that's 75 degrees. 75 degrees there. We're done with this one. We are done. All right, you must be extra careful, guys. Now, number 6. Oh, quite interesting, but this is very simple though. I'm sure you can see with a cyclic quadrilateral here. So that means if you add 4m plus 5m, those are opposite. 4m plus 5m, you must get 180 degrees. Right, so 9m is equal to 180 degrees divided by 9 divided by 9. So m is equal to 20. Right, so if m is 20, again, what it means is that if we add 4m plus 38 plus p, we must also get 180 degrees. So this is 4 times 20 there, plus 38 plus p equals 180 degrees. This is 80 plus 38 plus p equals 180 degrees. Right, 80 plus 38, we get 118 plus p equals 180. So p is equal to 180 minus 118. I get 62. All right, let's move on to the next one. So this is the last one. All right, so P, Q, R, and S are points on the circle. T is a tangent, TQ is a tangent at Q, intersects there at the with a center O. Interesting. Right. Remember, you don't answer these questions right away. So let's start by filling in the gaps. So QR is a chord, there's a tangent there. The same QR carries an angle at the circumference there, so that means this angle is 42 degrees. So if that is 42, that means this guy is 84 there. Also, angle subtended by the same chord at the circumference, this is also 42 degrees there. Quite nice. Right, what do we have? What else can we have here? By the way, this is 42 degrees as well, because this is a radius and that's a radius. So this is 42 degrees here. Again, this is 42 degrees there. All right, and quite funny. Right, what we need to realize also, this is another set of radii. So 84 from 180, I'm focusing on this triangle QOR. 180 minus 84, I'll get 96 divided by 2. Right, this means this angle here is 48 degrees. This is 48 degrees. By the way, this was supposed to give us 90, a tangent. So 48 plus 42 there, I'm sure we get 90. Perfect, so we are fine. So this is how much? 48 degrees, this one. Right, I think we're filled in everything. Right, angle QSR 42 degrees. Angle PQS that's 42 again. POS, this one is 84. Remember, vertically opposite angles are equal. That's 84 degrees there. Anything else? All right, we are done. Okay, so I hope you got something from this one. Please don't forget to subscribe, like, and share. See you next time. Thank you.